most of the like there's sometimes it's like a warehouse or yeah. I was like when I got next to me, so I was like and then stop somewhere, stop anywhere.
Yeah. Okay.
So this guy there wants to catch a. It was so funny. Because he like climbed over the railing of one of those crib walks there. And we're like, where's this guy? He's fishing and he's like gets his friends to get a hook and they just spear up his fish. Even the park ranger who came by was like, you can have it. I'm not gonna make you throw that.
All right. We already looked at some NMR spectra of thioethers, otherwise known as sulfides. And last semester and in the packet for IR, we also have examples of IR spectra of sulfides or thioethers. And I guess one of the most important things in terms of how these spectra and how properties, both physical and chemical, of sulfur analogs of these oxygen compounds. One of the things that will be most important to that is the electronegativity. So oxygen has an electronegativity of how much?
3.5.
And sulfur? So sulfur is just about the same as carbon. Okay? Which is why, you know, in the IR spectrum of a thion, you don't see an OH peak because it's kind of buried under the CH peaks. And these issues, the electronegativity relative to that of oxygen, and also the size of sulfur relative to that of oxygen, is going to have a significant impact on what sulfur compounds behave like physically and chemically in comparison to oxygen. And so sulfur is right below oxygen in the periodic table. So if we think about the thiols first, and this is kind of just summarizing some stuff really quickly. So some of these values we can fill in from before, where the boiling point of ethanol is about 78 degrees. The boiling point of methanol is about 65. And this value we had before for 1-butanol has a boiling point of 117 degrees. So the analogous sulfur compound has a boiling point here of 98. So even though it's larger and more polarizable, right, the significant difference between that and this is, right, that the sulfur analogs can't form intermolecular hydrogen bonds. So ethane thiol has a boiling point of 35, and methane thiol is only 6 degrees. If you have the misfortune to work with thiols in the lab, as I did as a graduate student, the ritual you'd have to go through is like, you know, you leave the lab and either on your way out the door or on your way in the door of your apartment, you take your clothes off and probably drop them in a solution with some bleach right away, because thiols stink to no end. I mean, they're the foulest smelling organic compounds you could ever imagine. For example, I think it might be, which is it now? Maybe butane thiol or something that they'll add to propane in cooking gas cylinders or whatever, so that when there's a gas leak, you'll actually smell it, okay? So picture that kind of smell, really, really concentrated. And yeah, 10 times worse than that's a thiol. Okay. So now in terms of their pKa's, what's the pKa of an alcohol's proton, just about? What's the pKa of an alcohol typically? In what range? It's around 16 or so. Right? What would you expect the pKa of a thiol to be in comparison to an alcohol? Lower or higher?
Lower.
So it's a bit
Right, so if it's lower, the pKa of a thiol is typically maybe around in the region of say 8 to 10, depending on the specific thiol. Meaning that a thiol is a very strong acid, or a much stronger acid